Hi there. Today, we are going to run a realistic DevOps interview focused on performance and latency problems that do not have obvious answers. This is the kind of interview where nothing is fully broken, dashboards look mostly fine, but users are still complaining that things feel slow. I want you to treat this like a real interview. Pause the video after each question. Say your answer out loud. Explain how you would think through it under pressure. Then listen to a strong sample response and compare your approach. If this kind of interview practice helps you, subscribe so you do not miss the next one. Let us begin. Warm-up behavioral questions. First question. Tell me about a time when users reported slowness, but your monitoring showed everything was healthy. How did you handle that situation? A strong answer here sounds grounded and calm. I would start by acknowledging the user experience as real, even if the metrics look fine. I would avoid arguing with dashboards. My first step would be to clarify what slow means to users, which actions are slow, and whether it is consistent or intermittent. Then I would correlate user reports with any subtle signals like tail latency, P95 or P99 response times, queue depths, or error retries. In one case, average latency was fine, but cache misses caused occasional slow paths that hurt real users. The key is validating user impact and widening the signal, not assuming the system is healthy just because alerts are green. Next question. Describe a performance issue you struggled to reproduce in lower environments. What did you do next? A strong candidate would say something like this. I accepted early that lower environments often do not mirror production load, data shape, or network conditions. Instead of trying to force reproduction locally, I shifted to safe production observation. That meant adding lightweight metrics, enabling sampling on traces, and running controlled experiments like changing traffic shape or temporarily isolating a component. In one case, the issue only appeared under specific data skew and concurrency. The lesson was to observe production carefully while minimizing risk, rather than assuming the issue had to be reproducible in staging. Next question. How do you balance urgency and correctness when investigating a live latency incident? A good answer shows maturity. I prioritize stabilizing user experience first, even if I do not fully understand the root cause yet. That might mean scaling out, temporarily disabling a slow feature, or shifting traffic. Once the system is stable, I slow down and investigate methodically. I also communicate clearly with stakeholders about what I know, what I do not know, and what actions I am taking. Rushing to conclusions often makes things worse in performance incidents. Next question. What is a mistake you made early in your career when debugging performance issues? A strong answer is honest. Early on, I focused too much on single metrics like CPU or memory and ignored system interactions. I once spent hours chasing CPU usage when the real issue was lock contention in a shared database table. That taught me to think in terms of request flow and bottlenecks instead of isolated resources. Let us move into technical scenarios. First question. Users report slow responses, but CPU, memory, and disk usage are all low. Where do you start? A strong response starts by reframing the problem. Low resource usage does not mean low latency. I would look for waiting rather than working. That includes thread pools, connection pools, database locks, external API calls, and network latency. I would check P95 and P99 latencies instead of averages. Then I would trace a request end to end to see where time is actually spent. Many latency issues come from contention, retries, or serialized paths rather than raw resource exhaustion. Next question. How would you explain the difference between average latency and tail latency to a non-technical stakeholder? A strong answer uses simple language. I would say average latency tells you how fast the system is on a good day. Tail latency tells you how bad the experience is on a bad moment. Users remember the slow moments, not the average ones. Even if 90% of requests are fast, the remaining slow ones can dominate user perception. That is why we care about P95 and P99 metrics. Next question. You notice that latency spikes happen every few minutes and then recover on their own. What are some possible causes? A thoughtful answer would list patterns, not guesses. Periodic spikes often point to background jobs, garbage collection cycles, cache evictions, auto-scaling events, leader elections, or batch workloads competing for resources. I would correlate the timing of spikes with deployments, cron jobs, database maintenance, or scaling activity. I would also check whether queues are building up and draining in cycles. Next question. How do retries impact latency, even when error rates are low? A strong candidate explains the hidden cost. Retries can multiply load and stretch request times. Even a small retry rate can push tail latency higher because slow requests get retried and stack up. From the user perspective, the request feels slow, not broken. I would ensure retries are bounded, have backoff, and are paired with timeouts. Otherwise, retries turn small hiccups into system-wide slowness. Next question. If you could only add one new signal to debug latency issues, what would it be and why? A strong answer shows prioritization. I would choose distributed tracing with latency breakdowns. Metrics tell me something is slow. Traces tell me where and why. Even sampled traces can reveal unexpected dependencies, serialization points, or network hops that are invisible in aggregate metrics. Tracing changes how quickly you move from guessing to knowing. That concludes this part of the interview. Pause here and reflect on which questions felt easy and which ones exposed gaps in your thinking. Next question. You are seeing high P99 latency, but P50 and P95 look normal. Error rates are low. How do you approach this without overreacting? A strong answer starts by accepting that P99 represents a small but real group of users. I would first validate whether P99 actually maps to user pain or just a few outliers like background jobs or internal traffic. If users are complaining, then P99 matters. I would break P99 down by endpoint, customer segment, and request type to see if the slowness clusters around specific paths. From there, I would trace those slow requests to identify whether they are blocked on a dependency, waiting on locks, or hitting cold paths like cache misses. I would be careful not to optimize blindly because chasing extreme tails can sometimes introduce risk. The goal is to fix meaningful user pain, not chase perfect graphs. Next question. Imagine latency increases after a deployment, but CPU and memory usage actually drop. How do you reason about that? This kind of scenario often means the system is doing less work, but waiting more. I would suspect changes in request flow rather than resource pressure. Maybe a new feature added an extra network call, introduced synchronous behavior, or changed batching logic. I would compare request traces before and after the deployment to see where time shifted. I would also check whether connection pools or thread pools are being underutilized due to blocking. The key insight is that lower resource usage does not equal better performance. It can signal that requests are stuck waiting instead of executing. Next question. How do caches both improve and hurt latency at the same time? A strong answer acknowledges the trade-off. Caches reduce average latency by serving fast responses, but they can increase tail latency when misses occur. Cold starts, evictions, or uneven key distribution can cause some requests to fall through to slow backends. I would look at cache hit ratios over time and correlate misses with latency spikes. I would also check whether cache stampedes are happening where many requests miss at once. Sometimes adding protection like request coalescing or warming strategies matters more than just increasing cache size. Next question. You suspect a database is the source of latency, but query times look fine. What else do you investigate? I would widen the scope beyond query execution time. I would look at connection pool saturation, transaction contention, and lock waits. Even fast queries can queue if connections are exhausted or long transactions block others. I would also examine network latency between the app and the database, especially in cross-zone or cross-region setups. Another angle is disk I/O spikes or background maintenance tasks that briefly degrade performance without obvious query slowdowns. The lesson is that databases slow systems in many ways that are not captured by simple query metrics. Next question. How do you decide whether to scale out or optimize when facing latency issues? This is a judgment call, not a formula. If the system is under load and users are hurting, scaling out can buy time and reduce pressure quickly. It is often the safest short-term move, but I treat it as a mitigation, not a fix. After stabilizing, I look for inefficiencies like N+1 calls, synchronous dependencies, or poor concurrency. Scaling hides problems and increases cost. Optimization reduces cost but takes time and carries risk. A mature approach uses both intentionally rather than treating them as opposites. Next question. What signals tell you that latency is caused by downstream dependencies rather than your own service? I would look for correlation between request latency and time spent waiting on external calls. Distributed traces are the clearest signal, but even without them, patterns help. If internal processing time stays flat while total latency increases, something downstream is slow. I would also check timeout rates, retry counts, and circuit breaker activity. Sometimes dependency issues do not cause errors, just slowness. In those cases, defensive timeouts and fallbacks matter as much as root cause fixes. That completes the technical core of this interview. At this point, you should have a clear picture of how performance problems often live in the gaps between systems rather than inside a single component. Let us move into the most uncomfortable part of the interview. These are the kinds of situations where there is no clean answer, incomplete data, and real pressure from users and leadership. Here is the first one. Your dashboards look healthy. CPU is fine, memory is fine, error rates are low, but users are complaining about slow performance and timeouts during peak hours. You have already validated that nothing obvious is broken. What do you do next? A strong answer here starts by acknowledging that metrics being green does not mean users are happy. I would shift my focus away from system-level metrics and toward user experience. That means looking at end-to-end latency, percentiles rather than averages, and recent changes in traffic patterns or usage behavior. I would check P95 and P99 latency, request queuing, downstream dependencies, and any recent deploys or config changes. If I still do not see a clear signal, I would temporarily add lightweight instrumentation or sampling to isolate where time is being spent. Throughout this, I would keep stakeholders informed that we are investigating a performance degradation even if the dashboards look normal. The key decision is to trust user reports and dig deeper instead of assuming the system is healthy. Next scenario. You are on call. Latency suddenly spikes across multiple services. Rolling back the last deploy might help, but the deploy included a security fix that leadership explicitly said should not be reverted. You do not know for sure if the deploy caused the issue. What do you do? In this situation, I would slow myself down and assess blast radius first. If user impact is severe and growing, restoring service takes priority. I would look for safer mitigations before a rollback, such as disabling a feature flag, reducing load, or scaling out capacity. If none of those help and evidence starts pointing toward the deploy, I would communicate clearly that we are considering a rollback despite the risk. I would frame it as a temporary stability measure, not a permanent reversal. The mature choice is not blindly following instructions or blindly rolling back, but balancing risk, impact, and reversibility while keeping leadership in the loop. Here's another one. You identify that a single downstream dependency is causing latency for multiple critical services. That dependency is owned by another team. They are slow to respond and believe the issue is not on their side. Meanwhile, users are impacted. How do you handle this? I would focus on reducing user impact first, even if that means working around the dependency. That could include timeouts, circuit breakers, caching, or temporarily degrading functionality that relies on that service. At the same time, I would gather concrete evidence such as traces, timing breakdowns, or correlation data to support the claim. When engaging the other team, I would avoid blame and stick to facts. My goal would be collaboration, not escalation. If needed, I would involve an incident lead or manager to unblock communication, but only after I have done my due diligence to confirm the dependency is a real contributor. Last scenario. You have spent hours chasing a latency issue. You have tried multiple hypotheses. None fully explain the behavior. Leadership asks for an ETA and a root cause. You genuinely do not have one yet. What do you say? I would be honest. I would explain what we know, what we have ruled out, and what the next investigative steps are. I would avoid guessing a root cause just to sound confident. At the same time, I would propose short-term mitigations to reduce impact while investigation continues. Mature engineers understand that uncertainty is part of complex systems. The key is communicating clearly, maintaining trust, and showing structured progress rather than pretending to have answers that are not backed by evidence. That brings us to the end of this interview. Performance and latency issues are some of the hardest problems in distributed systems because they rarely have a single clear cause. They live in the gaps between services, between metrics, and between what systems report and what users feel. If you are watching this as interview prep, I encourage you to pause and reflect on how you personally would have answered these questions under pressure. Which scenario made you the most uncomfortable? Which one felt the most realistic, based on your own experience? If you want more interviews like this that focus on real-world judgment, trade-offs, and uncertainty, consider subscribing. Each session is designed to mirror how senior engineers are actually evaluated. Drop a comment and let me know which question was the hardest for you.